Okay, so in this video, let's talk about the hydration of alkenes. So basically, the reaction is like this. Okay, let's take a alkene like this one, double bonded CH2. So I'm going to add conc H2SO4 and then water, right? So what happens here is we are going to add a water molecule to our alkene. So, CH2. So here we are gonna add a hydrogen and OH gonna add here. So there's no double bond, right? For the main points, right? This also follows the Markovnikov rule, which means the hydrogen over here, the addition of hydrogen will go to the most hydrated carbon, and the next part of OH will go to the next carbon, and rearrangement can occur. These two you need to have a very good idea, right? So which reactions do we have the Markovnikov rule, how we can do the anti-Markovnikov rule, likewise. So this particular reaction follows the Markovnikov rule and the rearrangement can occur. So let's move into the mechanism. So in mechanism, first of all, what happens here is like we have H2SO4, right? We have H2SO4. So this H2SO4 will be deprotonated. So H plus will be formed and HS4 minus. It's either right, whether you have two H pluses and sulfate, it's okay. So here we have the H plus cations in our solution. Now here we have our alkene. So what happens here is just like in hydrohalogenation, the alkene go and attack our H plus. So just as I have told in our previous video, the carbocation will be formed as the most stabilized carbocation, right? So which is this one. So this is the major product we are going to obtain, right? So here, right. So this is our major product which we are going to obtain. So now what happens here is we have water in our solution, right? Here we have water in our solution. So the water molecule will donate one of its lone pairs to a positive charge carbon, which we will have here CH3, CH2, OH, right? So here we have this type of molecules. So now what happens is we have another water molecule, right? It will donate, so this is positive, right? This is positive, so it will donate a electron pair to this hydrogen to break this bond. So here we have CH3, CH, OH and CH2H. This is our final product. I hope you get the idea. This is the mechanism, which is a very simple one, just like in halogenation, right? So first step is this one. You need to have you need to mention it very well, and always when you are drawing the arrow pushing mechanisms, these arrows should represent the movement of electrons, right? So if you draw it this way, it's wrong, it's completely wrong. So always this is the electron which is going to be attacked to our electrophile, so always you need to show the movement of electrons. So let's move into our type of the reaction. But what is the type of this reaction? You just you can do it, right? We have explained it in our previous video. So first of all, there are four types. You need to find whether this is addition or substitution. As you can see, new bonds are forming right? New bonds are forming, new compounds. It's going to be added into our excited molecule, which is, this is an addition reaction. So this is a nucleophilic addition or electrophilic addition. So most often we can say it like the first component is going to be attacked over here is H plus, here H plus, which is an electrophile. So this is electrophilic addition reaction. This is the type of the reaction. Let's do an example, quick example for the hydration, right? So let's say we have a molecule like this one. Here we have CH3. So we are going to add conc H2SO4 and water. So like in this case, in some textbook the reagents is noted as diluted H2SO4. It's completely fine, right? Some textbook prefer to say like this and some textbook prefer to say like this. Both are fine, but I hope this is the correct way. Like, it's your choice, right? So what's happening over here is, first, the hydrogen should be attached to the most hydrogenated carbon, in this case this carbon. So here we have the molecule. So here hydrogen is attacked over here, and here we have a methyl group which is stabilizing our carbocation. So our H2O will attack over here. So this is the reaction, this is the product which we are going over here, right? If your particular paper asks for a minor product, you need to mention the other product as well, right? Like this, the product should be the other carbocation which is not stable one. So in that case, CH3, the hydrogen will go and attack over here, so OH will come and attack over here. So this is not the case, like, yes, this is the minor product, but we don't have a very considerable amount is forming in practical aspects, so we are not considering this product as in practical aspect. So this, we consider this is the only product because there is only very small amount of this minor product. So this is our major. So I hope you get the idea about the hydration of alkenes.